So we went over the first, second, and third equation of motion. With first equation, we are talking about finding velocity here, finding velocity. So this is set up to find final velocity, but honestly, if you had final velocity and you needed initial velocity, it's just like solving any equation. So as long as you have all but one of the variables, you can probably find it, right? The second equation has to deal with position or displacement, as does the third. It just depends on what you have. So the second one, what you'll notice is that you have time. You have time in both of these. You're trying to find overall displacement. How far did they go, right? Something like that. Or where did they stop? What's the final position, right? The third one, the difference between the second and the third is I don't have time in the thirds. So I'm still trying to find displacement, but I have both of the velocities. I have the acceleration. I'm trying to find position, but I have both velocities, acceleration, and initial velocity, right? And so the only difference between second and third is what you've been given versus what you have to find, all right? I did say label units because I do want you to think about the fact that they could give it to you in centimeters and you have meters per second or something like that. I also want you to think about what you have, what you've been given, etc. So it says a hamster in its ball starts from rest and it accelerates to 3 meters per second in 6 seconds. What was the distance the hamster traveled? What was the acceleration? Okay, so a couple key things here. They are asking about distance and they are asking about acceleration. That's what we're going to end up looking for. Keywords in this problem. It says a hamster in its ball starts at rest. If I were to assign that a variable, what would I assign that? If I were to assign this a variable, I would say that is v of I. That is his initial velocity there. Accelerates to 3 meters per second. Don't let the word accelerate throw you off. 3 meters per second, when it says pay attention to your units, 3 meters per second is not acceleration. What is 3 meters per second here? If I were to assign this particular piece a variable, then what would I assign this variable? So this is going to be my final velocity. In 6 seconds, I'm going to assign that a variable as well. What is my 6 seconds going to be assigned? So this is going to be my change in time. The first thing I'm looking for is distance. Distance. What variable do we give the overall distance that we traveled? Change in x, all right? And then acceleration. What do we give acceleration? A, and it has, this is going to be average acceleration, For change in x. So we're going to go back to our equations and we're going to figure out which equation gives me change in x when I have initial velocity, final velocity, and time. When I look at all of my formulas, I need acceleration. They asked for it second. When I solved this, solved for acceleration first. All right? So when we look at average acceleration, this is from really the first thing that we did. Average acceleration is going to be the difference between your velocities, right? Your velocities over your time, correct? So my velocity, my final velocity, minus my initial velocity over my time, right? If I just take my velocity over my time, my average velocity over my time, I should be able to do this. So when I do this, I'm going to say 3 over 6. What am I going to get here? 0.5 meters per second squared. Meters per second squared. The reason it's meters per second squared is because this was 3 meters per second. This was 6 seconds. So your units are 0.5 meters per second squared. Significant digits. The measurable data that was given to you was 1 significant digit, 1 significant digit. So I gave you 1 significant digit in the answer here. We have solved for acceleration first. We're now going to go back to that first question and we're going to say, okay, now I have acceleration, initial, final velocity. I have time. What's going to be the easiest one for me to use? All right, so we chose this equation. If I want to find then delta x. What is my final velocity that they gave me? 3 meters per second, and I'm going to square that, right? And I'm going to subtract 0, right? So that really doesn't affect anything, even if I square it. All over 2 times my acceleration, which was 0.5 meters per second squared. All right. On the top, what do I get? I get 9, and as we mentioned, this is technically meters squared over seconds squared, correct? On the bottom, I get 1. This is positive because they said it accelerates. Meters per second squared. What I was talking about with your units is a quick check is my seconds squared and my seconds squared will cancel. One of my meters will cancel, and I'm left with 9 meters. Is that a valid answer if I'm finding distance? Yes, it is. A ball is dropped from rest. The time it takes for the ball to reach the ground is 5 seconds. What was the velocity of the ball just before it hit the ground? All right. So a ball is dropped from rest. I'm going to assign a variable to that. What am I going to assign? I'm also going to assign something else. Something else. All right. Key word here is dropped. If something is dropped, we actually know something else about it. What do we know? The word dropped means I also know its acceleration, don't I? Yes. I also know its acceleration because it was dropped. So the only acceleration that's happening to it is gravity. Gravity is the only acceleration. Gravity is the acceleration here. It does not have its own acceleration like the hamster did. The hamster has legs and a brain to move its legs. It has its own acceleration. A ball being dropped does not. It only has gravity working on it. All right? The time it takes for the ball to reach the ground is 5.0 seconds. That's also important. What am I going to assign to this 5.0 seconds? Delta time. And then what was the velocity of the ball just before it hit the ground? What am I going to assign to this guy right here? Final velocity, v of f. All right. So I have initial velocity is going to be 0. I have a final velocity that is going to be what I am solving for. I have acceleration, which we can actually say is gravity, which we know is negative 9.81 meters per second squared. And then I have a change in time, which is 5.0. How are we doing with these? Good? Y'all feel better about these now than you did when we did the equations on Monday and Tuesday, by chance? All right, 2 more, and then I'm going to let you work. All right. Let's look at the third one. Do y'all have all this before I move? All right, third one. Right, so this 40 meters per second that it gave me is going to be its initial velocity. It slows down to 10 meters per second. That is going to be my final velocity. They tell us that happens in 60 seconds. That is going to be my change in time. How far does it travel? It's very important that I know what I'm looking for. What am I looking for? Yeah, distance. So we're going to denote that change in x. Change in x. So I have final, initial, time, and I want change in x. All right, so before I can calculate my displacement or my distance, I'm going to have to calculate that acceleration. All right, so acceleration, I'm going to take my 2, and I'm going to say my initial, all right, or my final, minus my initial over my time. All right. So in this case, I'm going to get negative 30 over 60. What is my acceleration here? Yeah, negative 0.5 meters per second squared, right? That's just 60 seconds, not 60 meters per second. Sorry. That is my acceleration. All right. So then, just like on the first one, I'm going to choose to use the easier of the two. All right. So now that we know which formula we're going to use, we're just going to fill in what we know. We don't know change in x. We do know our final velocity. Square that. We're going to subtract our initial velocity. Square that. And we're going to put it over 2 times our acceleration. All right, so go ahead. We're going to square. We have 10 squared. Of course, your units also square there. We're going to subtract 40 squared. And then we're going to divide that by negative 1. $1,500 meters there. 1,500 meters. Question on that?
Can you show me how they...
To cancel your units here, on the top, you're going to have negative 1,500 meters squared per second squared over negative 1 meters per second squared. Remember, when it's fraction over fraction, you can cancel denominator to denominator. So both of those will cancel. One of those will cancel. You're left with 1,500 meters. So I went back in for significant digits and did this on purpose so that I would know that you were going to leave it in 2 significant digits. Just so you know, I just did that obviously before I printed and not after. So if you want to add your significant digits in your problem so that you know why you did what you did, go ahead. This says a car accelerates uniformly from rest and after 12 seconds has covered 40 meters. What are its acceleration and final velocity? What are its acceleration and final velocity? All right. So let's see what we know. Car accelerates uniformly from rest. What do we know about from rest? Initial velocity is going to be 0. After 12 seconds, what did they just tell us? Change in time. It has covered 40 meters. What did they tell me there? Change in x. What are its acceleration and its final velocity? I am looking for acceleration. I am looking for final velocity. So average velocity is going to be all of my velocity divided by 2, right? If I have 2 grades and I want to figure out what my average grade is, I'm going to take those 2 grades and divide by 2, right? Well, if I take my average velocity and multiply by time, that should be how far I traveled. So I'm kind of backing into something so that I can use what I need for the equations that I'm trying to find. So if I know my initial velocity here is 0, I do not know my final velocity. I just pulled the 1/2 in front. I do know my time. And I do know, I'm writing it in the wrong place. I do know my time and I do know my displacement. Then I can solve for my final velocity here. Because it feels like when you first see this question that you don't have enough information, all right? But we know if we take our average velocity times our time, then we should get how far we traveled. If you're going 60 miles an hour on average for 3 hours, you can figure out how far you traveled, right? So when we start to solve this, you can combine these two. 6 v sub f, because it's just going to be plus 0. And then you're going to divide both sides by 6. So your final velocity here is going to be what? So yeah, it's going to be repeating decimal. Look at all of the things you've been given. What are your significant digits here? 2. So you're going to take this 6.7 meters per second. 6.7 meters per second. So to find to find your final velocity, you're going to assume an average times time will equal your covered distance, right? So your average velocity times how long you traveled that average should equal how far you traveled, right? And that's pulling from how we derived that formula. So I have final velocity, and then I have all the things that initially gave me. So I'm starting again on this one with the second part of the question to figure out the first. Because once I have my final velocity, then I can just say, well, my final velocity minus my initial over my time, which was how long? We already know, 12 seconds, right? That should equal my average velocity. That should equal my my average acceleration. My average velocity that I ended up with helped me find my final velocity. Acceleration is just final velocity minus initial velocity divided by your time. 0.56. This time it is acceleration, meters per second squared. Couple things to check because you're going to have a tendency to not pay attention to your positives and negatives. If I started from rest and I covered an amount of ground, my acceleration should be positive, right? If I started at something and slowed down, my acceleration should be negative. So think about the logic of your questions as you're going through them.